Good evening all.
Good evening.
How are you? So, why we are joining to take a exercise in human presenting video. So, what's your topic today?
Using diodes.
Using diodes. So, we had so many discussions on that, right? So, how op-amps are used as diodes? That is what we are going to do. Actually, we are going to implement our presenting in 5 stages and discuss about op-amp as diodes. Right? So, it's going to start.
So the first day we designed the new load and study. So I have found out 4 main methods here, like the precision rectifiers. So when we talk about precision rectifiers, is like it is used in the ECG. There is a sudden voltage drops and spikes, so which leads to the distortion. So this is one method, and the second one is like a peak detectors, where the noise is used to store in the higher amplifications. So this is one, and the clippers and the clampers, where basically the clippers is used to safeguard the electric circuits and clampers is used in the receiver and communication systems. So the question is like we can able to solve this. Basically, the electronic circuits in these 4 have like a voltage drop and spike suddenly. So the question is like, are we going to rectify this using the op-amp using diodes? Is this possible or not?
Find the problem clearly. A normal diode-based rectifier uses 0.7 voltage by making inefficient losses of low voltage, and second one is peak detectors fail to store
Inefficient spikes.
Clampers get affected by clippers and clampers get affected by non-linearity of diodes. So our goal is to use op-amps with diodes to create linear high precision and low loss diodes.
Yeah.
So I'm going to continue the Ideate part. So as we know that Ideate is the benchmark design thinking, where we can come up with the effective solutions for the problems. We have to think out of the box to give the solutions. So based on this, I'm gonna give the solution for this for op-amp using diodes. The first one will be precision detector. So instead of using the simple diodes, we can use op-amps in the feedback input to control the voltage supply. And the next one will be a peak detector. So instead of using that, we can add op-amps in the diodes and capacitors to store the voltage levels. And the next one will be clippers. So using op-amp, the voltage signal is clipped and the values are stored very effectively and accurately. And the clampers using op-amps, the waveforms are generated and it is shifted without any distortion. So these are the Ideate part.
And by analyzing the ideas mentioned by her, and prototype demonstrate the practical implementation of these circuits. And first for precision rectifier, operational amplifier, diode and resistors. Or by analyzing the ideas mentioned by her, prototype demonstrate the practical implementation of these circuits. And first for precision rectifiers, operational amplifier, diode and resistors are the parts which we need. And here operational amplifier helps the diode to work perfectly, so that even very small signals can be rectified without losing its voltage. And it helps to provide a full rectified wave without usual 0.7 voltage loss from normal diode. And next for peak detector, operational amplifier, diode and capacitors are the parts which we need. And here operational amplifier charges the capacitor to the highest input voltage so that we can use it until it resets. And it's useful for radio receivers and detecting signal waves.
Let me explain about how do circuit protect high voltages under signals accurately. The solution is using clippers and clampers. Clippers is limit voltage to prevent damage. Clampers are used to signal transfer. Clippers are applied in signal processing under power supply. Clampers are used in audio communication.
By testing the prototype, we have the final results and the comparison without op-amp and with op-amp. Without op-amp, we have the traditional mode, and with op-amp, it is improved circuit. By rectification, it offers 0.7 voltage, and with op-amp, there is no voltage loss. wherein detection there's no fall and no downfall in the with op-amp, then downfall without op-amp, which is very serious. In tripper, this is unstable in the waveforms, wherein with op-amps is stable and shock mindset. Whereas in clamper is discontinuous waveform shift, wherein with op-amp they have continuous and straight waveform shift. At launch, with op-amp means with no voltage drop and now accurate performance.
So, to the raised question in the empathy part, like can we solve these issues using the op-amp using diodes? I think based on analyzing all the 5 stages using the design technique like the empathy, define, ideate, prototype and testing, we can able to know that the answer is yes. Yes, we can rectify the issues in the precision rectifiers, peak detectors, filters and trackers. So yeah, that's all. We got to know the answers like yeah, the solution is yes, we can able to solve.
Yeah, very good. Nice interaction, and I think you have implemented all the 5 stages in this concept. Thank you.
Thank you.